In 2010, researchers published a study showing the crash risks of alcohol-impaired driving. They used data from that many car crashes to show the relationship between driver's blood alcohol and the risk of being in an accident. The data from the report was used to create an exponential model of the relative risk of car accidents as a function of blood alcohol. The data is shown in the figure above, and the error associated with the model is shown in the figure to the right, where the error is the difference between the actual rate and the projected value. Which of the following conclusions is best? Well, it looks like we have exponential, and our error seems to go really wacky whenever the blood alcohol is higher. Now, I would say, based off of this picture here, that you do have an exponential model. This picture shows a model, which means this picture is just not linear. Okay, if it shows an obvious pattern, it means not linear. Looking at the picture on the left, I know it's exponential because exponential looks like that. Okay, so an exponential model is not appropriate? No. It is better to overestimate the relative risk of alcohol impairment driving to ensure readers understand the dangers. I don't think that's what's going on here. I don't disagree. Because the error is greatly increased after a blood alcohol of 0.15, the model should only include the interval 0 to 0.15. Maybe. Because the risk of accident is so high after a blood alcohol of 0.15, the model should only include the interval between, no. So I guess C would be your guy, because after 15, like the data seems to be way off. So they might be like, you know what? Let's just count everything up to here and not worry about that. So all that nonlinear talk had nothing to do with this problem, but this residual plot looking thing right here is pretty valid up to this point right here. And once we get beyond 0.15, it goes haywire, just like drunk driving is.